So I heard some of you talking about this. What do you think?
Number 2.
Yeah, definitely number 2. Seems kind of crazy. We're gonna give you some information today to prove that, okay? And moving from our polynomials, okay, to exponential today. You'll see what that might look like here in a second. All right. Exponentials. This is what an exponential equation looks like. It's going to be in the form y equals some b to the x power. It can have many different bases. There's certain bases that we can't have. But this is an exponential equation because the unknown is where? It's in the exponent, okay? We've had exponents before. You would know what 5 to the second, okay? But really now we're looking at 5 to the x. The unknown's up there. There are ways to solve for unknown exponents, which was using logarithms, which we're going to get into. If you would, you're going to need your graphing calculator, so you can pull that guy up. You're going to need a regular calculator too. Here's some of the stuff we've done. A positive linear, y equals mx plus b. Here's a -1, that'd be y equals negative mx plus b. We've done some of those. We've done quadratics where they are coming down, crossing the x-axis, x squared. Okay, so that'd be ax squared plus bx plus c, where we had plenty of those. We just finished those with some more polynomials where we're crossing quite a bit more often, which we just finished up. So now we're going to exponential, which look like this. So the definition there, an exponential function with a base of b, so it can have different bases, is divided by f of x equals bx. Remember f of x and y, so we could also write it as y equals bx also. Notice there are some stipulations on the base. Has to be greater than 0, it can't be a negative. And there is one other thing, it can't be 1. Because if you thought about that, if your base was 1 to any power, whether what's 1 to the 10th power? 1, what's 1 to the 100th power? So 1 doesn't work. Some basic examples, as you can see right here, of what exponentials look like. We can have whole numbers, fractions. We can have decimals with a multiplier outside. So those are just different types of exponentials. All those have the same thing in common, and that is what? Where is the x? The x is in the unknown part. Questions here? Anybody else? Note takers good? Just remember, where's your unknown? Boom, exponent. Boom, exponent. Boom. All right, take a second and see if you can put that in your calculator and graph it. See what it looks like. So your first part would be y equals 2 to the 0. What is 2 to the 0?
0.
Is 1. So your x is 0, your y is 1. So that's going to put us right here. X at 0, y at 1. We could put 2 to the first. What would that be? 2. So your x is 1, your y is 2. We can put 2 to the second. That's going to be 4. So now you're looking at 2, 4. And you're going to notice this shape should look something like that. It doesn't go past that on your calculator, so. Exponential. That's the kind of shape you got. Now it's going through your 0, 1, because anything to the 0 power for your x is going to be 1 there. What's a growth? That's a growth, okay? Definitely growth. Decay is going to look a little different, okay? You might start like this, and it's going to come down and go like that, okay? So we have studied the inverse. That would be the inverse of a big kind of sandwich if it is the same. If it would be the same rate. All right, this guy right here is what we're going to use all day today and some tomorrow. So get him down, and this is all we're doing today. I'm trying to understand this guy right here. So our output is our final amount, and this would be our Gini problem that we looked at today. We would be plugging in our initial amount, and that was 2 pennies, right? Our initial amount was 2 pennies. And then our rate was, in that case, it was doubling, so be 1 plus 1 there. Most of the time that rate's gonna be in a percentage. And then your time up here, time. Most of the time, we're talking about years. Sometimes we'll throw some minute problems at you or some hour problems, but a lot of times it is year. So this is your basic formula to calculate any exponential growth or decay. So this rate, or this part right here, dictates whether it's a decay or a growth, okay? So you're gonna read the problem and say, well, is this a decay or a growth? A growth. So if it's a decay, it's gonna be 1 minus. So if it's decay, okay, that's gonna be less than 1, so 0.90, that's a decay. 0.50 is a decay. So this part, if it's less than 1, it's a decay. It's a growth, okay? If this part right in here might be 1.5 is a growth. 1.0625 is a growth. Anything greater than 1 would be a growth. So we got 2 types here, growth and decay. As you look at the problem, you'll have to figure out. So this is really cookbook math, okay? How many things do we have here? 1, 2, 3, 4. So I'm going to give you a problem. How many of those things do I have to give you? I don't have to give you all 4 of them. I'm at least going to give you how many of them? 3. Almost always I'm going to give you some type of rate. Look for it. Okay? Sometimes you'll have to find the amount. Sometimes you have to find initial amount. Not very often, though. Most of the time, 99% of the time, you'll be finding time or final amount, okay? How we doing with this guy? Everybody okay? Got it down, those of you who want it? All right, here we go. First problem. First of all, read it, and you decide if the growth or decay? Let's all decide that here. Read it and see if you think it's a growth or a decay. Anybody? It definitely is growth, right? Okay. Now, what are we trying to find? When it's worth what?
10,000.
So where's 10,000 go?
The equal sign.
Okay, so 10,000 is on this side. Where's the 5,000 go?
On the right.
Okay, it's going right here next.
Or left, right.
That's my money I started with. So this is gonna be 1 plus, I gotta write this as a decimal. How's that as a decimal? It'll be 0.0625. So 1.0625. What's my unknown? My unknown is what? How many years, which would be my x value right here. Or time. So in fact, what I'm really trying to find is how much time it'll take to get to 10,000, right? Okay. How you wanna go about it? Remember a game you played probably sometime in elementary? You played this game. I got a number between 0 and 100. See how many guesses it takes you to get it. What was the first thing you'd ask me?
50.
Is it bigger or lower? I say yes. Is it bigger than 50 or lower than 50? I say yeah, it's higher than 50. Okay, so now you're down to between 50. That's one guess, right? So one guess. Now what would you say? Is it higher or lower than? And I'd say higher. So now you're down to between that. Make sense? And then you would say whatever and keep going. Well, we're kind of going to do that with this. What do I want to plug into X? Try 10. Grab your calculator, try 10. See how much money we have after 10 years. Real simple, just put 10 right there. So put this straight in. You don't need to graph it. You don't need to do anything. Let's guess and check. So 5,000, put your bracket, 1.0625 raised to 10.
Oh, we're close.
You already did that part. I added that rate. It's 1 plus that. That gives you your rate in there. Anybody getting 10 years? How much money we got?
9,167.
9,167. So it's a bigger than 10. I'll jump up to 12 years. So plug in 12 now.
12 to 5.
You might not be. Try and see.
It's 1,300 or 10,300.
10,300. So where is it? Probably somewhere between.
11.
Yeah, around 11. 11 is probably going to be short. So there you have it.
Oh, so you just noticed in between those two? That's all you did?
Well, you can say around 11 years and I would accept that.
Awesome.
You like the guess and check game?
Yeah.
It's not that hard, is it? Okay, go to y equals in your calculator. Go to y equals if you have the graphing one. Put this in right here. The y equals 5,000, 1.0625. Use your caret to the unknown x. Go to y equals, put that in. What did we start with, 5,000? 5,000? Don't worry about what it looks like. 1.0625, correct? Raised to the x and hit graph. Just leave it on Zoom 6. Don't mess with your window because I don't really care to see it. Okay? What I want to see, don't worry about what I'm doing now. I'm changing something just so you can see it. What I want to see after you graph it, I want to go to the table. So hit graph and then go to your table, which is second graph, which we've been to already this year. You should get what I got.
Oh, I'm at 2,000.
Yeah, I didn't get that.
So started at 0, go second window, hit 0 here, started at 0, and then go back to your graph. Second window, you can start it at 0, you can hit your cursor around.
How do I fix this? Like it has me at, like on the X is 2,268.
Just set up, here, I'll do it for you. Second window, go to 0. Now, hopefully it makes sense to you. What is X? X is what?
0.
Years, right? So listen to the problem. What's the problem about money, right? Interest. So the first day she put the money in there, 0 years. How much money did she have?
5,000.
What I started with, right? How much money did she have after 5 years?
6,700.
Okay. Now, we already figured it out, but that was the guess and check thing. You see how your calculator can give you multiple output values in like a nanosecond.
How'd you get there again? What was it?
Well, I went to y equals, I put it there. You got that?
Yeah.
Hit graph.
Yep.
You have to graph it. That way it loads into the table. It won't load in. Then second graph gets you the table. Now, here's how you move around in the table is second window. What if I want to go down to year 21? I can just jump down there. And yeah, 17,000. If I want to go back to year 1, or around 0, there you go. So that allows you to move around in the years if you want. You can also, I even go one more step, you can change it, let's say, what did we say, it was around 11? So we'll go to year 11, but I'm gonna jump down here, instead of every year, I'm gonna change it to point every 10th of a year. Let's see what we get there, you'll notice a difference here. So now the calculator is breaking those down to 11.1, 11.2, 11.1, okay? And we get really accurate, looks like it's gonna take what? 11 and a half years. Now you get kind of tricky when you have to convert that to months, so that'd be what? 11 years, 6 months. Where do you get that at? Second window. You can change that around, but most of the time you probably want to keep that on 1. But it is good to know, not 10. It is good to jump from 0 sometimes. You gotta jump up pretty high. That's a good thing to jump around. So in fact, this done the same thing as we did as guess and check, didn't it? But it was done really quickly with a whole bunch of numbers. So listen, if you are looking for a certain amount and you do not know the time, it's really good. We'll go to y equals and then Decay, because it can give you all kinds of amounts for different times in a very quick fashion instead of doing the guess and check game. Make sense? Okay. First thing is figure out if it's what? Growth or decay. What is this one?
Right.
You
Wait, no.
see the word
it's
dropping
decay.
in there?
I just saw the word drop. I saw positive number.
Is this a candidate to use the graphing table? Yeah, we're searching for time. If you do not know the amount of time it takes to do something, that's when the graphing table will be helpful. So write the equation, go to your y equals, see if you can get it in. Gotta graph it so it loads in the table. Then you're looking for your output value to be what? 8,000. How many years is it gonna take to fall below 8,000? Now, could you guess and check it? Well, certainly. You could guess and check, but it is pretty quick and simple if you use the graphing table. So really our equation that we're gonna put in our calculator would be 15,500. Okay, you gotta be careful here, what's going in this guy? That's important, you gotta get that part right, we're looking for 8,000 here. What's going in those brackets, it's gonna be 1 minus 0.03. Need your calculator, do it, but that's really 0.97, notice, 0.97, is that less than 1? Anything in there less than 1 is a decay. If it's greater than 1, it is a growth. You want to guess and check, or you want to use your calculator? That's the question for you. I would too. What do you got to do? Go to y equals 15,500, bracket 0.97, bracket raised to the x. Have to graph it or it doesn't go in the table. Now, for this problem, unless I specify, you can estimate between 10 and 11 years, between 50 and 51 years. Does that make sense? What's this one?
Between 21 and
21.
I think it is between 20 and 21 years. Okay? I'll put it in mine and go through it one more time, so pay attention. Huh?
21, 22. Yeah.
21, 22? All right, 21 to 22 is my bad. Here we go, watch. Y equals, right? I'm gonna clear out what I had in there. I had 1,5,500 to start with, correct? I'm deteriorating at 3%, which is 0.97, close, raise to my X. Graph. Do I care what it looks like?
No.
I could care less. Don't mess with the window, just leave it at zoom 6. I don't care, I don't wanna see it, why? Look, the intercept is 15,500, I wanna get out that far? Because that was your initial amount. Table. Well, I'm looking for 8,000, an option is just to scroll down. And there you had it, 21 to 22 years. Another option, we can jump around by going to the table set, go back up to 0, that's fine. Okay, you can jump down to 21. You can also break it into smaller increments if you really care to. All right, so it looks like 21 and 7/10 of a year. So you have to figure out what 7/10 of a year in months. You can use a proportion to get that if you really want to get nitty gritty. You can even get down to days if you wanted. You put 7 over 10 is equal to what over 365? You get the exact years to days. Make sense? Now that's kind of some nerdy math, but. All right, do the world population. You guys doing great, hanging in there. Growth or decay? What do you think? Population growth or decay? Yeah, it's growing. Okay. So we're looking at 6.08 billion, 1.0121 here. Do I need my calculator for this one other than a quick calculation? No, because I know everything that I need to know on that side of the equation. What I don't know is my output. So I need my population after how many years? What year is this for? How much, what do I want? So what needs to be my X? 20. So 20 goes here. So you're gonna get 7 point something billion. Anybody have their phone handy?
Yeah.
Google population of the world right now.
7 billion.
See how close it is. We'll see how close it is.
Got 9.21.
What are we getting for our calculation up there, anybody?
9.21.
I think that's a little high, I don't think it's 9
It's
billion.
7.8 billion.
Yeah,
Yeah.
is that the Google?
Yeah.
Okay, so Google's telling us 7.8 bill. What's our calculation telling us?
7.73.
Okay, so it's pretty steep and close, isn't it? We're off a couple billion, we're off a couple million.
7.7.
Google, how many people die each day?
There's a lot.
20,000.
Oh, there's more than that.
Probably like a million something.
People that die in the world.
How many people die each day?
I think it's 25.
25 million, maybe.
Yeah.
Million?
Yes.
Wow, listen, you're talking 8 billion people.
Oh.
Yeah, but 25 million is a lot. Per day.
Nearly 150,000 people
Sounds a little high.
die per day.
150,000?
Yeah.
In the United States, or that's the world?
Oh, I thought COVID deaths.
Forget it, but we'll move on.
It was stupid.
You get it.
World death rate, what's that mean?
That's the world death.
Oh, okay. It's a growth rate.
7.7.
So death rate is 7.5. And
Move on. Do this last one. Predict how much a computer is worth after you buy it. There are a few things that depreciate immediately as soon as you buy it. One is a computer. Anybody know the other? Yes, the car.
Oh, yeah.
As soon as you turn the key and it's yours, you just lost. If you buy a new one, you just lost probably $5,000.
2,600.
So remember, if you buy a new car, you just paid about $3,000 to $4,000 for that smell. That new car smell.
I mean, the smell is pretty. I wish I could get like an air freshener.
They have it. And a new car. And a new car smell.
I'm still got
Decay or growth here. Make sure you get what's going on. Okay, 30%. So 3,000. You gotta be able to write these equations. What's going in the bucket there?
4.
Uh-uh.
Oh, 0.97.
What? What's going in here, anybody?
1 minus 0.03.
It'd be 1 minus 0.3.
0.
30%.
Oh, I thought it was 3%.
Yeah, 3% would be, then it would be 0.97 in there, but what's it gonna be? Point what? 0.7. What's going there? We're X,
4.
not X, but 4. What's it worth after 4 years? $5,000, 500, 600, 700? You don't have to you don't have to go to Y equals, all you gotta do is do a quick calculation there.
20.30.
700?
720.3.
Okay, what if I asked you to figure out when it was worth 100? Okay, when's that worth $100? Now, here's where I'm going to go and use my table. Do you see why? I could guess and check there. It's gonna take me a while, I put 20 years in and see what it's worth, but the table's pretty slick there. So I just go Y equals 3,000, 0.7, raise to the X, graph it, go straight to the table. How soon till it's worth 100? $10 years, 12 years? Anybody grabbing it?
It's not gonna be 100 since it's decreased, right?
Yes.
Oh, wait, never mind.
It's decreasing.
$100, it says 1 even negative 12.
So 12 years,
I don't know.
you got it wrong.
I got it in wrong? What? I
But
don't
you get the idea, right? Anybody get it? Mine, when's it worth 100? Trying to get in there or no? No.
Oh, yeah, hold on. It's in between 9 and 10.
9 and 10 years.
Just go back to the table.
Thanks.
You know, this is a quiz that I could probably get.
Classic trash can.